Thank you for joining this lesson. We're going to study quantity of heat, book 3 physics, number 15 of the paper. We are taught to define specific heat capacity. So this term is used in quantity of heat. Specific heat capacity is the amount of heat energy which is required to change the temperature of a unit mass of a substance by 1 unit, or rather by 1 Kelvin. So that amount of heat energy required to change a unit mass, because of the word specific, a unit mass of a substance by 1 Kelvin. We call it specific heat capacity. Part B, we are given some data from an experiment here, whereby we are told in an experiment to determine the specific latent heat of water. Steam at 100 degrees Celsius was passed into water contained in a well-lagged copper calorimeter. The following measurements were made. Mass of calorimeter 60 grams, initial mass of water 80 grams, then initial room temperature of water 15 degrees Celsius, final temperature of the mixture 45 degrees Celsius, final mass of water, calorimeter and condensed steam 160 grams. Then the last part, we have specific heat capacity of water as 4200 joules per kilogram per Kelvin, and specific heat capacity of copper as 390 joules per kilogram per Kelvin. Determine part 1, mass of the condensed steam. So we will have steam condensing by being passed in cold water, which is at 15 degrees Celsius, which is inside a calorimeter. Therefore, water and calorimeter are at 15 degrees Celsius, but steam is at 100. Then the steam is being passed in that water, which means the steam will lose some of its heat energy into the water, and by that, some steam is going to condense. Then we are taught to find now that mass of the condensed steam. So the mass of condensed steam is going to be given by, we will have the final mass of water, calorimeter and condensed steam as 160. Then we subtract the initial mass of water and calorimeter. So initial mass of water was 80 and calorimeter 60. So they are having 140, but now when steam condenses now in them, we are realizing they are totaling to 160. So there is a 20 gram mass which has been provided by the steam which condenses in the process. Part B, heat gained by the calorimeter and water. So heat gained by calorimeter and water, we can start with the calorimeter. Heat gained by calorimeter. You know, heat energy is given by mass times specific heat capacity times change in temperature. So the mass of the calorimeter, 60 grams. So 60 out of 1,000 to make it as a unit. The calorimeter is made of copper, whose specific heat capacity is 390 times change in temperature. They were initially water and calorimeter at 15 degrees Celsius, but finally at 45 degrees Celsius. Therefore, the change in temperature will be from 15 to 45. Therefore, we're going to compute this amount of heat energy, whereby we will take 16 times 390 times 30 divided by 1,000, and this gives us 702 joules of energy. Then on the other side, we have heat gained by water. Heat gained by water. Water is having a mass of, the initial mass of water was 80 grams. So we shall use 80 and the specific heat capacity of water times the change in temperature still to 45 from an initial temperature of 15. This is going to give us, when we take 80 by 4200 by 30, then we divide by 1,000, we're going to obtain 10,080 joules. 10,080 joules. So the total heat energy now which will be gained by both water and calorimeter, will be when we add 702 to this figure, and we get 10,782 joules of energy. So that is the heat energy gained by both water and calorimeter. Part 2, given that LV is the specific latent heat of evaporation of steam, write an expression for the latent heat of vaporization of steam. This should be vaporization, not evaporation. Vaporization of steam. Write an expression. Therefore, what we should understand is that as the water and calorimeter gains heat, steam loses it on the other side. Therefore, we shall say heat lost by steam now is going to be the heat lost by the steam to first of all condense. And you should know that steam condenses, heat of vaporization. This is going to be given by mass times latent heat of vaporization, because it happens at a constant temperature. There will be no change in temperature. Therefore, in this case, we shall have the mass of the steam which condensed, we make it as a unit, times their known LV. Then now, after this steam has condensed, it will be water at 100 degrees Celsius. But now it cools until it is 45 degrees. So from 100 to 45, water is going to cool. Therefore, heat lost by condensed steam, or rather now, by the water from steam. These are different water from steam, not the water which was initially in the calorimeter. Therefore, we're going to employ its mass times specific heat capacity times change in temperature. Therefore, we shall have its mass, 20 grams, divided by 1,000, times 4200, times a change in temperature from 100 to 45. This is 55. Therefore, when we compute this figure, 20 by 4200 by 45, by 4200 by 45, then we divide by 1,000. We're going to get 3780 joules. So the total heat energy lost, by steam is going to be, this one becomes 0.02 latent heat of vaporization. Then now it cools by losing 3780. These are all joules of energy. Then part B of the question now is telling us to determine, part C of the question, to determine the value of LV, the specific latent heat of vaporization. So this value is now going to be obtained by, when we come here and argue that the amount of heat energy lost by steam will be equal to the amount of heat energy gained by water and calorimeter. This is with an assumption that there is no heat loss to the surrounding. Therefore, we equate the amount of heat energy lost by steam to the amount gained by water and calorimeter on the other side, 10,782. So we're going to remain with 0.02 LV equals to 10,782 minus 3780, which is giving us 7,002. So to remain with this figure, we're going to divide through by 0.02, and this gives us 350, 100. Latent heat of vaporization is given in joules per kilogram. Remember, there will be no per Kelvin, because this process of change in state happens at a constant temperature. Thank you for following. Subscribe and share.